Hey friends, it is let's see, it's October 7th, uh 2025, and we are live with Mr. Z and Matt. So let's see what we can do to share our screen and do some math. Here we go. We are in Kami, which is a fabulous little app. And so here we have your parent functions that every algebra and pre-calculus and calculus student should know. The thing to remember is that if you ever forget how to graph something, you could always, for instance, for a line, y equals x, plug in a negative, plug in a positive, and then you get a feel for what's going on. The only two graphs that are um, linear, or at least sort of, are lines and absolute value, because absolute value is really a line, but the tail end of it gets popped back up because whatever was negative is now positive because absolute value means distance from zero. Everything else will be a curve. So just to make sure, here we go. Um, make sure you're seeing what I'm seeing. And so even if you have y equals x squared, what's important to remember is that when you put in 1, you get 1, you put in 2, you get 4, 3, you get 9, and so now you have a curve. And remember, if you're not sure what to do on the left, a negative times a negative is a positive versus x cubed, a positive times a positive times a positive, a negative times a negative times a negative is a negative. So notice the end behavior. When you have an odd power, the positive will go up, the negative will go down. If somebody throws a negative in front, it'll just flip upside down. And now let's take a look at square root and cube root. Okay, keeping in mind, if it's going to be a function, a square root, you're only concerned with the top half. Otherwise, if you talk about the bottom half, it will not pass the vertical line test. So when you talk about the square root function, as in like f of x equals the square root of x, you must consider the fact that you can only take the top half of it. You'll notice, however, a cube root, and you can't take the square root of a negative, so that has a limited domain. And so if you take a look at the domain, you will notice that the domain is limited. And however, y equals the cube root of x. Let's pull this in a little bit. I'm going to pull you in over here and get rid of that. Get rid of that. Here we go. So when we are taking a look at cube root, you'll notice how a cube root actually has a front end and a back end. Now, when you take the root of something, it gets smaller, like the cube root of 8 is only 2. And you can actually take the cube root of a negative because a negative times a negative times a negative is a negative. And just like a cube graph goes like this, it's very similar to this. It actually has two ends. Now, log. A log is just an exponent. A lot of students don't need to know the log graph quite as often. But say, for instance, you ask yourself if it was log based 10. So 10 to the what gives you 1. 10 to the 0 gives you 1. Um, 10 to the first gives you 10. And so let's take a look at what they're talking about here. So the log base 10 of, say, 100 is base 10, excuse me, that's a 10, is 2. So way out at 100 would be 2. So depending on what the root is, excuse me, what the base is, the numbers will change. You'll notice how that's the inverse of exponential functions because logs are actually exponents, and so they're inverses of each other. So look at it this way. If your exponent is 0, anything to the 0 is 1. And how about we do, um, even if we do, let's see, b to the x. B to the x, b is greater than 1. Let's take a look at the function. It's very good SAT skills as well. If b is greater than 1, how about 3 to the 1 is 3. So when I put in 1, I get 3. When I put in 2 for x, I get 9, and so on. So even if it's just something similar, it'll come out pretty close. Now you'll notice how there is an asymptote there. So you'll notice how things will get infinitely small, but they're never going to hit, just like a rational function. Okay, so this sometimes can be looked at as x to the negative 1. You will notice how 1 over infinity or close to infinity is really close to 0. And you cannot put 0 in there. So you notice how the domain, because friends don't let friends divide by 0, you will notice how the domain x cannot be 0, and therefore it's going to hug this asymptote. And if we put in a million there, it's still not going to quite get to 0. And if you put in a negative, you also get a negative. 1 over a negative is a negative. So the two sides are in opposite places. 1 over x squared is a little bit different because when you square a negative, you get a positive. So it's the same basic graph, except the left half of it is right side up. And of course, we have y equals 5, y equals 2, etc. Notice it's y equals 0x plus b or c. B is the y-intercept, so it actually has a slope, but it is 0. And then we have the greatest integer function. So the greatest integer function is one of your infamous step functions where they ask you, what is the greatest integer inside that number? So what's the greatest integer between 1 and 2? It is 1. And when you get to 2, it jumps up. So let's clarify this. So what's the biggest integer between 1 and 2? It is 1, and then when you get to 2, there's an open circle there. And then it goes open circle. We'll make these a little thinner since we're zoomed in. So the greatest integer between 1 and 2 is 1. And then between 2 and 3 is 2. And we jump between 3 and 4 is 3. And you'll notice how it starts with a closed circle. And the greatest integer at 3.99 is 3. And then it jumps and so on. This is called a step function. This function is not often used. That function is not often used. You don't see it very often. However, it does have its applications. And so there is a little introduction to parent functions. Now, keeping that in mind, let's take a look in a book. In the next video, we'll take a look at how you graph parent functions in vertex form. My suggestion to you is if you're watching this and you need to learn a little bit about graphing parent functions or remembering them, is to take a piece of paper, draw them out, and keep in mind that if you don't remember how to graph something, you can always plug in 0, plug in 1, plug in -1, and see where you end up. And know the fact that you can always try a couple other numbers as well if you're not sure about the shape. But pretty much anything with an exponent is going to go up. Anything with a root or a log is going to go kind of sideways. And the only ones that come out as lines are lines and absolute values. So everything else is a curve, including sine, cosine, tangent, all those other trigonometric functions. So I hope you have a fabulous day. And when you watch this, my suggestion is to watch it on 1 1/4 to 1 3/4 speed so that you don't get bored. Because I know how I watch videos. So whenever I watch math videos, I tend to watch them on 1 1/4 to 1 1/2 speed, if not faster. And I will sometimes just scroll through so I can follow what's going on and go, okay, I get it, I get it, I get it, I get it. So, um, cheers to everyone. And next video will be graphing in vertex form. Cheers. And let's end that stream.